This video contains the solutions to take-home problems number 28. For these problems, we're looking for the vertical asymptotes and the coordinates of any holes in the graph of these rational functions. So the way that we're going to find these is by first looking at the domain, because any value of x that's not in the domain is a place where we're going to have, for a rational function, either a vertical asymptote or a hole. So the domain here, just like we've done before, we set the bottom of the fraction equal to 0 and solve. In this case, we get one solution, x equals 1. Now what we do is we plug that value of 1 into the top of the function. And when we plug it into the top of the function, if we get 0, then that means that we might have a hole. But when we plug this value into the top, we get 6. And so f of 1 we can think of as being, and I'll put this in quotation marks because we can't actually do this, but it would be 6 divided by 0. So what it really means is that when x is really close to 1, what we get is a number that's really close to 6 divided by a number that's really close to 0. Dividing by a number that's really close to 0 gives us a really big answer, and that's what's showing us that we have an asymptote, a vertical asymptote, at x equals 1. And that was the only value of x that was not in our domain, so we're done. So another problem, same idea. Find the domain by setting the bottom of the fraction equal to 0. So we have x squared minus 4x minus 5 equals 0. We can solve that by factoring. So we get x minus 5, x plus 1. That gives us x equals 5 and x equals negative 1. So we're going to test these separately. Let's start with x equals 5. We plug this into the top. And when we plug it into the top of the fraction, we get 5 plus 1, which is 6. So again, that means that f of 5 is, again putting it in quotation marks, 6 over 0, and that means that we have a vertical asymptote. Now when we test x equals negative 1, when we plug that into the top of our fraction, we get negative 1 plus 1, which gives us 0. Now that means that we might have a hole. It's not a guarantee that this gives us a hole for sure at that point. It just means that there's a potential hole. So how do we find out whether we actually have a hole? Well, what we want to do is reduce the fraction if we can. So we have x plus 1 on the top, and on the bottom we have x minus 5 times x plus 1. That's our factored form that we got from finding the domain. And we see that indeed we can reduce this, and when we reduce this we get 1 over x minus 5. Now what we see is that x equals negative 1 is no longer excluded from the domain of this new simplified version of our fraction. So that means that when we plug in x equals negative 1, what we get is 1 divided by negative 1 minus 5. That's going to be negative 1/6. And that tells us that since we didn't get something divided by 0, that we have a hole at the point negative 1 comma negative 1/6. So these are our solutions. We have a hole at negative 1 comma negative 1/6, and we have vertical asymptote x equals 5. Another similar problem. So we again look at our domain. Our domain is to set x cubed minus 9x equal to 0. We can factor out an x. That gives us x squared minus 9. And then we can factor this further as x minus 3 times x plus 3. That's a difference of 2 squares. So that gives us 3 solutions, x equals 0, x equals 3, and x equals minus 3. Test each of these separately. For x equals 0, we plug that into the top. And that gives us 4 times 0 plus 12. And that's not 0, which means we have a vertical asymptote at x equals 0. Similarly, when we plug in x equals 3, in the top of our fraction, we plug in. We get 4 times 3 plus 12. That's 24. And that's not 0, so we have a vertical asymptote at x equals 3. Finally, x equals negative 3. When we plug that into the top, we do get 0. 4 times negative 3 plus 12 equals 0. So that means potentially we have a hole there, and the way that we find out if we actually have a hole is by factoring and seeing if we can cancel out a common factor. So we already factored the bottom. We know that that's x times x minus 3 times x plus 3. We can factor the top by factoring out a 4. And look, we see that we can cancel out the x minus 3. That gives us 4 divided by x times x minus 3. Now when we try to plug negative 3 in, we don't end up dividing by 0. When we plug in x equals negative 3, what we end up with is 4 divided by negative 3 times minus 3 minus 3. That's 4 divided by positive 18, which reduces to 2/9. And so that means that we have a hole at the point negative 3, comma, positive 2/9. So here's our conclusion. We have 2 vertical asymptotes and 1 hole for this function. Another similar problem, so we've got x plus 1 divided by x squared minus x minus 12. So we want the domain. We set the bottom equal to 0. We get x minus 4 times x plus 3. That gives us 2 solutions, x equals 4 and x equals negative 3. Testing those separately, when we look at x equals 4, we plug that into the top. What we end up with is 4 plus 1, which is 5. That's not 0, so we have a vertical asymptote at x equals 4. And when we plug in negative 3, same thing happens. When we plug into the top, we get negative 3 plus 1, which is negative 2, and that's not 0. So that means that we have a vertical asymptote at x equals negative 3. So 2 vertical asymptotes for this one and no holes. Another similar problem, when we look for the domain, we set the bottom equal to 0, x squared minus x minus 12. This is the same denominator from the previous problem, so we already know how it factors. X minus 4 times x plus 3 gives us 2 solutions, x equals 4 and x equals negative 3. We test these separately. X equals 4, we plug into the top. And we get 4 plus 3, which is 7, and that's not 0. So we get a vertical asymptote at x equals 4. But for x equals negative 3, when we plug that into the top, we get negative 3 plus 3, which is 0. So that means we potentially have a hole. The way we find out whether or not we do have a hole is by taking that fraction, the original function, and trying to see if we can cancel out any common factors on the top and the bottom. We already factored the bottom when we found the domain, and we see that we do have a common factor of x plus 3 on the top and the bottom. That gives us 1 divided by x minus 4. And now when we try to plug in x equals negative 3, now we can do it without dividing by 0. So we get 1 divided by negative 3 minus 4. That's negative 1/7. And that tells us that the coordinates of our hole is negative 3, comma, negative 1/7. So we have a hole, and we have a vertical asymptote.